Now up to the second method. Limit of a function using factorization method. Examples. We have example 1, example 2. Please, I would like you to pay full attention in this particular, to these particular examples, because let's pay attention. So first example, we have to limit this expression x squared minus 4 all over x minus 2 as x tends to 2. If you look at this, we can easily say that we should use direct substitution method here. But let's give it a trial. If we use direct substitution method, what are we going to have? If we should put the value of x naught, which is 2 here, put it here, we're going to have 2 minus 2. Denominator will give us what? Will give us 0. And for any expression, whenever we have denominator to be equal to 0, it is totally undefined. So for that reason, we cannot use direct substitution method in this case. So what are we going to use? This is where the second method, factorization method, comes in. What are we going to do? Now, if we want to factorize and split it out, we have something like our x plus 2, x minus 2. Because if we should open these brackets, add the two together, we're going to have x squared minus 4. I don't know whether you understand what I'm saying. So moving further, this still remains our x minus 2, the denominator. And we are still limiting the expression as x tends to 2. This is still the same thing as the initial question we are given. So from here, we can see that a factor of the numerator is the same as the denominator, which is very much which makes it very much possible for us to rule out this part. I will say this denominator rules out this part of numerator. Now we have this. We are still limiting the expression as x tends to 2. But from here, we are left with x plus 2. So if we look at this, we can see that it resembles the one we did last time using substitution method. So from here, we can directly substitute the value of our x naught, which happens to be 2, in this particular expression. So let's go with that. It's not going to be equals to x. Okay, whenever we see x now, we put the value of x naught, which is 2. So here we have 2 plus 2, which equals to 4. So that's the last answer for this particular expression. Don't forget, when we started, we substituted this value of x naught in the denominator, and it returns 0, which renders this expression undefined. If you have something like that, such issue like that, we can't solve it using the direct substitution method. What we are going to use is this method we call factorization method. I believe you understand. Now let's move back to the second example. Please, I would like you to pay full attention here as well. Full attention. The question says, bracket, x plus h squared minus x squared all over h. Let us test the same thing we did to this one. If we input the value of our h naught, in this case, to this our expression, we are going to have what? 0 as denominator, which makes this particular expression as well undefined. So in this case, what are we going to do? Can we factorize out anything here that will rule out this denominator? I guess the answer is no. So in this case, what we are going to do is to reframe, to redesign this particular expression. What can we do here? The first step, let us expand this numerator. We open the bracket by expansion. This implies that we are still limiting the expression as h tends to 0. Now, let us open this bracket, x plus h all squared. Using binomial expansion, what do we have? We have x squared plus 2xh plus h squared and minus x squared all over h. I believe you are following. Now, if we look at this, we can see we have x squared here, x squared here. One is positive, the other one is negative. It means this can rule out the second x squared. So this one rules out this. What are we left with? We have 2xh plus h squared all over h. We are still limiting the expression as h tends to 0. From here, if you should input the value of h naught, which is 0, in this expression, it will still be undefined. So, now look at this very well. From the numerator, we can do something. What are we going to do? We can factorize out h from these two values because h is a common factor to both. So if we factorize out 2, what do we have? We have h open bracket 2x plus h all over h, limiting the expression as h tends to 0. So this h rules out this. I believe you got that one right. Then we are left with our h tends to 0, 2x plus h. 2x plus h. And from here now, this one looks almost the same as this, which gives us the room to use direct substitution method here. Now, if we should directly substitute the value of h naught, which is 0, we are going to have what? We are going to have 2x plus 0. And this is equals to 2x, which is the final answer. So in this case, I will advise you to go over to this process again and ascertain for yourself how we get this final answer. I believe it's very much explanatory enough. If you have any question, you can drop it in the comment section. We are going to address your issues. Thank you very much.